MCEN 1131 Engineering Mechanics, Statics, Friction and Belt Friction, prepared by Mirko Dumanovic. Belt friction. There are two main assumptions that we will make in this section. 1. A rope, cable, or flat belt is used. Notch belts and V-belts require further analysis. And 2. To visualize how the rope, cable, or flat belt is moving, we visualize a rope wrapped around a fixed cylinder. The rope's position is such that it is on the verge of slipping. In Figure 1a, a rope is passed over a fixed cylindrical beam. Due to downward force P, weight W is on the verge of moving upward. Due to friction between the cylinder and the rope, force P must be larger than weight W. In Figure 1a, a rope is passed over a fixed cylindrical beam. Due to downward force P, weight W is on the verge of moving upward. Due to friction between the cylinder and the rope, force P must be larger than weight W. Notice that the friction force is acting in a direction opposite to the direction that force P is pulling the rope in. Figure 1b shows the force of friction on the rope with respect to the cylinder. The rope is on the verge of moving. Thus, the cylinder exerts a force on the rope as shown in the figure. Slipping. Figure 1c depicts the impending slipping of the rope around the cylinder. The difference between TL and TS depends on two things. 1. The coefficient of friction, mu, and 2. The angle of contact, theta. This difference is expressed using the following equation. Log base 10 TL over TS equals 0.434 mu theta. Recall that TL is the large tension, TS is the small tension, mu is the static coefficient of friction, and theta is the angle of contact in radians. An alternative equation that uses natural log is ln TL over TS equals mu times theta. This can further be reduced to TL over TS is equal to e to the exponent mu times theta. Here, e, the Neperian constant, is 2.718. Mu is again the static coefficient of friction, and theta is again the angle of contact in radians. Your choice of which belt friction equation to use depends entirely on your own personal preferences. To avoid confusion, it is recommended that you choose one belt friction equation and stick with it. Here are 5 hints to help you in your problem solving. 1. The direction of the friction force will always be opposite of the direction in which the object moves. For flat surfaces, friction force runs parallel to the surface. For curved surfaces, friction force runs perpendicular to the radius of the curve and is located at the point of contact between the surface and the rope. 2. The friction angle is located between the resultant force and the normal force. The angle is expressed in radians. 3. If motion is not impending, then mu does not equal to F max over n, and F and n must be treated as any other two unknowns. 4. Don't draw a vector triangle without first drawing a free body diagram showing the same forces. And 5. When solving for TL or TS in the equation natural log TL over TS equals mu times theta, keep in mind that TL over TS must be treated as a single term until both sides of the equations are anti-log. That is to say that the natural log of TL does not equal to TS multiplied by mu and theta. Homework. Read Chapter 7 from pages 255 to 266 and complete the practice examples and problems from the book as well as those provided by the instructor.